For decades, satellites scanning the Arctic Ocean have captured something easy to dismiss. An odd discoloration, a shifting shadow, a thermal ripple behaving unlike anything else in the polar record. Year after year, the anomaly grew, changed shape, expanded, and influenced distant patterns. Scientists admit they don't fully understand what's happening beneath the ice, and the satellite evidence is deeply unsettling. Subscribe for more deep ocean mysteries grounded in real science and history. The first hints appeared in the late 1970s when early US and Soviet satellites mapped polar sea ice. Analysts noticed a dark patch that didn't match seasonal melt patterns, where ice thinned faster than surrounding regions. It was dismissed as instrument error, yet even then, the anomaly's shape showed structure rather than randomness. When higher-resolution satellites launched in the 1990s, the anomaly gained definition. What was once a vague discoloration became a distinct, nearly circular form spanning kilometers. Ice fractured in straight lines, curved arcs, and sudden fissures that ignored wind and current models. Proposed explanations failed to explain the consistent geometric patterns. By the early 2000s, the anomaly doubled in size. Thermal sensors detected a faint but persistent heat signature rising from below the ice, slowly weakening it. No hydrothermal vents or tectonic activity existed in the region to explain it. Something beneath the Arctic ice was generating warmth through an unknown mechanism. Around 2004, satellites observed the anomaly drifting across the Arctic basin. Natural melt zones don't migrate cleanly, yet this one moved deliberately, against expected currents, maintaining its circular form over hundreds of kilometers. If it were simple warm water, it should have dissipated, but instead it behaved like a coherent mass. Global attention grew in 2011 when satellites detected a pulsing pattern. Ice above the anomaly rose and fell rhythmically, displacing surrounding flows and radiating cracks outward. Some proposed pressure waves or trapped heat bursts, but no known Arctic geological process produces rhythmic pulses sustained over decades. Retired analysts later admitted similar pulses appeared earlier, but lacked reliable data. Improved sensors confirmed the pattern. Each winter, pulsing intensified beneath thicker ice. Each summer, the thermal signature spread outward, forming scorched-looking streaks that resembled tendrils extending from a growing central core. Altimetry satellites detected subtle damming above the anomaly. The ocean surface rose several centimeters in a perfect circular swell, indicating massive water displacement from below. Hypotheses included rising plumes or under-ice gyres, yet the structure was too consistent and disconnected from known currents to fit normal dynamics. Magnetic mapping satellites later recorded faint but persistent distortions directly above the anomaly. These resembled signatures found above metallic deposits or seamounts, yet none existed beneath the ice. Ice movement couldn't explain them. No existing natural model accounted for the anomaly's magnetic fingerprint. By the mid-2010s, the anomaly spanned an area larger than some European countries. It subtly altered cloud patterns and atmospheric pressure systems. Though quiet, its influence on northern hemisphere weather became undeniable. Still, satellites could not see what lay beneath the ice, only the effects it produced. Oceanographers attempted direct measurements by deploying autonomous buoys. Many failed quickly due to sensor malfunctions and corrupted data. Surviving instruments recorded erratic temperature spikes, salinity drops, and upward-moving currents that defied known physics. These readings ruled out volcanic or methane-based explanations. Reanalysis of older satellite archives revealed the anomaly predated the 1970s. Reconnaissance imagery from the 1960s showed faint distortions in the same region. Grainy photos hinted at unusual ice breakage clustered around what would later become the anomaly's core, suggesting long-term persistence. Climate scientists found correlations between the anomaly's seasonal growth and jet stream deviations. Years of expansion coincided with weakened or shifted atmospheric patterns affecting storms in North America and Europe. While not blamed directly, the anomaly behaved like a silent underwater pressure node influencing the atmosphere. Marine biologists noticed whales altering migration routes to avoid the anomaly. Acoustic recordings captured sudden silences, as if something enormous passed through the area. Whales respond to pressure and low-frequency sound, suggesting the anomaly generated disturbances perceptible only to deep ocean life. Government agencies quietly took interest. Declassified US and Russian documents debated whether the anomaly was a massive geological structure buried beneath sediment. Yet submarine sonar never mapped a solid object. Instead, sonar returned vague, shifting reflections as though the ocean concealed something mobile. In 2018, hyperspectral imaging from a European satellite detected unusual light absorption. The anomaly reflected light differently from water, ice, metal, or rock. Analysts suspected a layered or composite material, possibly sediment in motion, but the data resisted precise interpretation. Seafloor topography maps revealed subtle elevation changes along the anomaly's path. Undersea ridges appeared to rise gradually, shifting sediment in smooth waves. Such migration contradicted known tectonic behavior. Some suspected warm currents, others an unknown deep water mass reshaping the seabed mechanically. Drift reconstructions revealed the anomaly followed a massive circular arc across the Arctic basin. The path was neither random nor linear. Too stable for wind, too broad for currents, it suggested a predefined trajectory, as though the anomaly followed an ancient curved track. Radical hypotheses emerged. Some proposed a vast under-ice gyre. Others suggested a migrating mantle plume or an enormous biological phenomena. None explained the magnetic distortions or rhythmic pulses. Every explanation solved one aspect while failing others. By 2020, the anomaly tripled in area. Seasonal resurfacing became clearer, darker, and faster. Scientists officially named it the Arctic Ocean Anomaly, acknowledging its existence without understanding it. Despite advanced instruments, it remained a shadow beneath the ice, growing stronger each year. Naval archives added new clues. Cold War submarine logs described unusual turbulence and sonar interference matching the anomaly's later path. Some vessels experienced sudden pressure fluctuations requiring emergency depth changes. Once dismissed as errors, these reports aligned too precisely with satellite data. Comparisons were drawn to thermoline chimneys, vertical shafts driven by salinity and temperature differences. But Arctic chimneys collapse quickly and migrate unpredictably. The anomaly persisted for decades, pulsed seasonally, and moved cohesively, defying all known chimney behavior. Methane hydrate destabilization was considered. Gas release could warm water and disturb ice, but gas plumes spread chaotically. The anomaly maintained crisp, smooth boundaries year after year. Its geometry suggested a physical mass rather than dispersed gas. Ocean acoustics revealed low-frequency vibrations when the anomaly passed hydrophones. The sound was slow, steady, and powerful, unlike ice cracking, earthquakes, or marine life. It resembled mechanical resonance, yet no human technology could operate unseen beneath the ice for decades. The anomaly influenced polynya formation. Circular openings appeared in ice, evenly spaced from the anomaly's core. These shapes suggested coordinated heat or upwelling rather than wind or currents. Their precision hinted at a structured force acting in harmony with seasonal expansion. Fisheries researchers noticed ecological aftereffects. Shrimp populations surged after the anomaly passed, while pressure-sensitive fish abandoned affected regions. Nutrients appeared stirred from the depths. Marine ecosystems behaved as though something massive had passed through, leaving a biological wake. Gravity-measuring satellites detected shifting mass anomalies. Water above the anomaly became fractionally denser over time. Though subtle, the measurements were statistically significant. Gravity does not change without cause. Something beneath the ice altered local mass distribution. Overlaying all datasets revealed the anomaly's true shape, a broad, cohesive mass stretching hundreds of meters deep. It produced heat, distorted magnetic fields, displaced water, and fractured ice. Geological explanations failed, yet biological ones were equally impossible. The salt lens hypothesis suggested hypersaline water drifting through the basin. But salt lenses dissolve quickly and don't grow steadily. Glacial debris fields were also considered, yet they leave sonar traces and sediment trails, none of which followed the anomaly. A high-resolution satellite later captured faint outlines beneath thin ice. The structure appeared darker than water and warmer than ice, large enough to affect cloud formation. It curved subtly, like part of something immense. The next pass showed nothing. The anomaly had moved again. As the anomaly expanded, warmer air pockets formed above it even during peak winter. These pockets altered storm timing and pressure systems locally. The phenomenon was no longer confined underwater, it had begun influencing the atmosphere above. International survey missions repeatedly failed. Icebreakers felt sudden vibrations, drones lost contact. Deep probes shut down unexpectedly. Aircraft magnetometers recorded interference. None of these effects were dangerous alone, but together they formed a consistent pattern of disruption. In 2021, infrared sensors detected a repeating 12-hour thermal cycle. The rhythm resembled biological, geothermal, or mechanical systems, yet matched none perfectly. Something beneath the ice was producing a steady repeating signal without intent. The anomaly maintained its temperature during extreme cold snaps. This implied a self-sustaining heat source independent of seasons. No vents existed. Biomass couldn't explain the scale. The thermal stability violated every Arctic model. Ice thickness imaging revealed radial fracture patterns spreading outward with mathematical regularity. Natural ice cracks are chaotic. These repeated geometries suggested a systematic force shaping the ice from below. Synthetic aperture radar showed surface ripples inconsistent with wind. Water appeared stirred from below in colossal motions. Some compared it to whale-induced surface effects magnified thousands of times, yet no biological mass could produce this unseen. Floating markers released into the anomaly behaved erratically. Some vanished, reappearing months later far away. Others looped in spirals. The data suggested complex under-ice currents, unlike any known vortex system. A multinational panel concluded no single natural explanation fit the data. The anomaly combined geological, biological, and mechanical behaviors. It resisted classification, behaving like something entirely new. In 2022, satellites captured a brief surface distortion as though something brushed the ice from below. A long arcing shadow moved beneath the sheet. Debate followed, but some insisted the shape appeared almost organic. As speculation grew, officials urged caution. Public statements emphasized climate change, shifting currents, and routine geological processes. But behind closed doors, research funding quietly increased, and new satellite systems were tasked with monitoring the anomaly year-round. The commitment of resources suggested an uncomfortable truth. Whatever existed beneath the Arctic Ocean was expanding, evolving, and no longer ignorable. Curiously, as the anomaly grew, scientists noticed a correlation between its movement and patches of unusually calm water visible from space. These glass-like areas appeared even during strong winds, forming directly above the anomaly and following its drift. Something beneath the ice seemed to dampen the ocean's natural surface turbulence. The anomaly's influence extended beyond water and ice. Atmospheric physicists observed subtle distortions in aurora formations passing overhead. Light curtains bent or shifted against expected magnetic field lines. Because auroras trace Earth's magnetosphere precisely, even small deviations implied an unknown interaction between the anomaly and the planet's magnetic environment. Attempts to simulate the anomaly consistently failed. Oceanic flow models could not reproduce its stable shape. Geological simulations required impossible heat sources. Biological explanations demanded mass beyond physical limits. Even unconventional theories collapsed under testing. The anomaly became one of the few modern phenomena that advanced computational models simply could not replicate. Some researchers proposed layered explanations, multiple processes acting simultaneously, including thermal upwelling, salinity gradients, magnetic displacement, and deep circulation. In theory, such alignment could create a complex drifting system. Critics argued that chaotic processes do not synchronize so perfectly for decades, nor grow with such steady acceleration. An unexpected breakthrough came from ice core analysis. Samples taken from regions the anomaly passed beneath years earlier showed microfractures arranged in parallel lines with consistent spacing. These patterns suggested oscillating upward pressure from below, leaving long-lasting stress signatures in ice long after the anomaly had moved on. Renewed focus on the anomaly's rhythmic pulses revealed they were increasing in amplitude over time. Each cycle subtly expanded its influence, affecting ice conditions farther from the core. Some scientists likened it to a slow, deliberate breath, unrelated to tides, yet consistent enough to sustain the internal driver. As media speculation intensified, sensational stories of hidden machines or giant organisms spread rapidly. Scientists publicly dismissed such claims while privately admitting frustration. The anomaly was too orderly to be random, too fluid to be solid, and too powerful to ignore, occupying a strange space between no natural categories. Hope now rests on next-generation satellites scheduled for launch. Equipped with deeper penetrating radar, gravimetric sensors, and advanced imaging arrays, they may finally reveal what lies beneath the anomaly's shifting core. Until then, researchers rely on indirect evidence that clarifies patterns while deepening uncertainty. For now, the Arctic Ocean anomaly remains a silent force drifting through one of Earth's most remote regions. It does not surface or announce itself. Instead, it expands steadily, reshaping ice, influencing water and air, and bending data into forms no one predicted. A rare mystery that grows under observation. Whether the anomaly represents an unknown geophysical process or something entirely new to science, its existence challenges our understanding of the Arctic. Satellites show only its effects, never its source. Beneath the ice, something vast continues to move, unseen, cold, and growing larger with every passing year.